Alright everybody, we made it to chapter 10. This is section 10.1. It's all about scattered plots or scatter diagrams, and then linear correlation is what we're really going to focus on. Before I start, you're going to want your formula sheet. We're going to look at one formula, and the very first one, the R equals formula on your formula sheet, so have that handy. And you'll also want your calculator so you can kind of see how to make your life a lot easier. So basically, scatter diagrams or scatter plots, you just plot your points. You know, X is the horizontal, Y is the vertical. We all kind of know that. We have what we call the explanatory variable as your X, and then the response variable, kind of what happens as you plug X in, is your Y. And then the goal basically is to determine if there's a linear relationship with any points. So here's two kind of pictures. The scatter diagrams, the first one on the left is the years of college to how much you make or income, and we plotted different varieties of data points. And then what we're going to do come next section is put a line of best fit in there. Okay, so once we find that line of best fit, that's what we're kind of look at for this whole chapter. So that's kind of the goal that we're going to do. So do all relationships make a linear point? No. Okay, so if you ever get some that end up like a smiley face or look like a paintbrush against the wall, they're not linear. Now the ones that you're going to have to create, yeah, they're most likely going to be pretty linear and right on. We're not going to completely waste your time. How strong of a linear relationship is very important though. Okay, so if the points lie exactly on the straight line, it's called perfect correlation. That is very rare. Okay, so it goes from perfect to strong to moderate to weak in that order. Is kind of the relationship, and it's not necessarily a fine line, but you can kind of gauge and make your best guess or estimate. Okay, so here's just a few more pictures, correlation examples. Here's a moderately strong positive because it's going up, moderately strong negative because it's going down, but you can kind of see where the lines are going. Like I said, the perfect correlation is rare, but this is when they're right on the line. Okay, and then the negative perfect correlation is when your line's going down. So that positive and negative is going to show up. What's the one thing I need you to take out of this section? The variable R. It's called the correlation coefficient. It's just the measurement that describes your correlation. So this R value does not have any units. It's going to range from -1 to +1. Okay? Logically, positive values is a positive slope, negative values negative. If you get an R value of 0, it's like a paintbrush against the wall. There is literally no linear relationship at all. And then just a few other things, interchanging X and Y's are not going to change your correlation at all. They're still going to make some type of line no matter if you change them or not. So that's just kind of the focus on that. Okay, just a visual example, R equals 0, they're all over the place. If you get an R equal 1 or an R equal -1, -1 is perfect negative correlation. The closer you are to 1, the closer to perfect it is. The closer you are to +1, the closer to perfect positive correlation it is. So that's when you see this number, you're going to be given an R value. You know, that might range from anywhere from 0 to 1. The closer to 1, the more perfect it is. The closer to 0, the more moderate to weak correlation. Okay, and then from -1 to 0, -1 is perfect, and then as you get closer and closer and closer to 0 on the negative side, it's getting closer and closer to weak or no correlation. So once again, getting close to 1 or -1, that's what's important. Now the next few slides I'm going to go through pretty quick. Developing a formula. Basically the idea is this, you know, you're going to have either positive when X and Y are both low or X and Y are both high. If one's low and one is high, then it's negative, and then if they're kind of all over the place, that happens as well. Developing this formula, how this works in a quick snapshot is you find your average, whatever the average of your X values are, and then you subtract that average from every single X value. Okay? Now once again, what makes positive and what makes negative? If both are positive or both high, then they're positive, hence both positive times a positive is positive. If they're both low or both negative, then they're going to be a positive correlation, and so on and so forth. Here's the formula, the crazy one, if you per se, that we'll never use, but you add up the sum of every Y value subtracted by its average divided by its standard deviation to make it unit free. So basically, if you take every Y value, subtract the average, okay, times every X value subtracted by its average, and add them up, and then divide by n minus 1 to take the average of them, that would be your R value. Now that would be absolutely horrendous to sit and do that. Now this doesn't look much better, but this formula is what's on your formula sheet. That's what we need to be able to do in this section. Not only I trust that all of you can make a scatter plot and do that in the first section, but what I want you to do is work on this formula. This is not simple. You got to be able to take these. You're going to need all of these different things in order to calculate this formula. You need the sum of x, the sum of y, the sum of x squared, sum of y squared, and the sum of x times y. Once again, somebody with way too much free time decided to be able to do this. This is important. Be careful. The sum of x squared is when you square all the x's and then add them up. The sum of x quantity squared is when you square the sum of all the x's. Just be careful which one is which. So now what I want you to do is plug all of these numbers into your calculator. Okay? So I've already done that. If I pull up my calculator here. Alright? Put all of those numbers. So notice that in L1 I put the x values, and L2 I put the y values. Okay? What I want you to do is be able to figure out all those 5 things, the sum of x squared, all those. So what you need to do is go to Stat. We're going to calculate, and now we always did the first variable stats to figure out our average and our standard deviation and all that stuff. What I'm going to do now is actually go to 2 variable statistics, because there's 2 variables that I'm doing, and I need to make this smaller. Okay, then I have the enter button. So if I do 2 variable stats, and now I have 2 lists, I need both of my lists. This thing needs to get out of here. Let's put him over here. Okay, I'm going to go L1, so second L1, comma, second L2. If I push enter, okay, now notice that I have my x bar. Okay, sum of x, we're going to see that 678. Sum of x squared, we're going to see that number. And then if you actually scroll down, the sum of y is in here, the sum of y squared's in here, and if you keep scrolling down, the sum of x times y is in here. You're going to need all 5 of those numbers in order to continue. So I guess it's bigger over here if you look, but I'm going to go back to my thing now. So what we're going to do, okay, x involves the wind velocity, y involves the drift rate of sand dunes, and we're going to see if there's a linear relationship to wind and the drifts of the sand. Okay, so notice that I talked about where sum of x, sum of y, sum of x squared, sum of y squared. Look at your calculator now and see if you can find those numbers. Because otherwise, if you don't use your calculator, you're going to have to take the 70 and square it. That's what 4900, okay? And you have to square all of them. And then you'll have to square the y values. And then you're going to have to go x times y. And you have to do all this stuff and add it up. That's going to be super annoying. Whereas if you just dump in your x's in L1, your y's in L2, and like I said, go 2 vars stats. Okay, L1, comma L2, you'll be able to get these numbers for you. Okay? And then if you go and find your formula, it's just a matter of figuring out what is going where. Okay? So what I'm going to do, I'm going to just go one line at a time. So notice that I have an n. N is just the number of numbers, so there's 7 in each list, so it's 7. The sum of x times y. So if I go back, the sum of x times y, that's the very last one that you had to scroll down to find, is your 18,458. Minus sum of x times sum of y. You all should be able to figure that out. But just remember, you have to do this number, subtract, these are together, and you'll get some number on top. Okay? Once you got that figured out, then you go to the bottom. Here's where it gets a little bit tricky. You have 2 radicals, and you have to do each radical separate. Okay, so n is 7. The sum of x squared, if you go back to your 67,892, minus, it's the sum of x, and then quantity squared. Okay, whereas the first one was the sum of x squared. See the difference between the two? So this is the x squared, and then you add them all up. The other one is the sum of x, and then you square it. Notice the difference between what 2 numbers are where. If you mix those up, big problems are going to occur. Then you multiply the other radical, and it's very similar. Okay, so n times the sum of y squared minus sum of y squared. Now you're going to have this formula. You just need to practice calculating it. So the top should be 16,658. Okay, the first radical, actually taking the square root, is your 124.74. The second radical is 140.78. And then if you figure that out and multiply the bottom first, by the way, and then you go 16,658 divided by the bottom, you get 0.949. Okay? So since r is positive and 0.949, there's a strong, because it's close to 1, positive linear relationship between the wind velocity and the sand dunes. Okay, so the faster the wind blows, the more they drift. And that's what you need to take out of that little semi-scenario. Okay, so that's what you're going to need to try and do and try and work on. So 0.949 is going to be your R. Okay, so this is R equals, and then you kind of need to write it as there's a strong positive correlation. Okay, difference between population and sample. I've emphasized this a lot, but your R values, your normal English alphabet, so that's a sample correlation computed from a random sample. Now this letter looks like a P, and you guys are going to make fun of me, but it's actually the Greek letter rho. Okay, that's the population correlation coefficient when you have all of the population. Once again, this is very rare, but this is the Greek letter, and it's actually spelled R-H-O, rho. Okay, so that's where it kind of comes from. Be careful. High correlations do not always imply a cause and effect relationship between these variables. I guess I should emphasize that before. The wind might not always cause the sand dunes to be very drifty. It might be some other reasons too, that it's really dry in the desert or something like that. Like in Fargo, high wind rate does not make sand always drift, so that's part of it. You might need to, there's other variables that might be in and amongst that. We call those variables lurking variables. Okay, this is a variable that's not even remotely connected to the two. So maybe in this case it might be rain, which is not necessarily connected to wind or sand. Okay, but it can cause a difference. They can be responsible for things that's kind of out of our control. So kind of another one that I know the book threw out there that I just was going to throw out. So countries with a high level of education tend to have higher cell phone bills. Is this necessarily always true? Not necessarily. Maybe the country itself is pushing education and pushing cell phones. I mean, there's other things in there that we just don't know, and we're going to talk about that in the next section as well. Correlation between averages is going to make the correlation higher when you have averages, because you get rid of your outliers, basically, is kind of the idea, so your correlation should be better. So these are just a few things. You will have a few questions about lurking variables. Please don't lose sleep over some of those questions, but it's just the idea of working about that. So here's going to be our assignment that we do in class, and hopefully you all have a wonderful day.